Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to look at the solution to the assignment that was given on lesson 6, okay, of uh, differentiation. In fact, we're looking at differentiation from the first word principles. Okay, so please take notes as you have on your screens. You have the solution I'm going to walk you through. And okay, the solution happens to be the marking scheme. So it's supposed to guide you to mark and send your capture and send your marked version to your various assignment submission platforms. Okay, so please take notes. I've gone through your submission. So as and when, okay, all the concerns that I saw in your presentation, okay, will be addressed. Okay, all right. So just as we have on our screens, find from the first principles the derivative of y is equal to x minus 3, the whole of that squared with respect to x. So we are differentiating this function with respect to what? X. And we know once you are differentiating this function with respect to x, indirectly we are asked to find d dx of y, which we know will end up giving us what? Dy dx. Okay, so that will help us, okay, quote the first principle formula. Okay, so as usual, remember I've told you, when you read question and you underline the salient part here, the salient part should be first principle so that you know that if you use any other approach, you'll be marked down. So you only have to restrict yourself to the first principle approach. Okay, so after that, the first thing that you write is solution. After solution, you extract the function, okay, that you are asked to differentiate, or the relation that you are asked to differentiate. So this must be extracted. And remember in our lesson 6, you were told that if the function comes in factorized form, okay, before you apply the first principle concept, okay, or before you start using that function, okay, in the first principle formula, make sure, okay, the function that you are going to use will not involve any brackets. So by that, you were told to expand any function that comes in its factorized form, meaning remove all brackets. So we all know how to deal with what? A binomial square, meaning how to expand a binomial square. So x minus 3 all squared, we know if you are supposed to use the concept of what? A minus b all squared. Okay, that's identity. We know this will give us a squared minus 2ab plus b squared. So here our a is x, our b is what? 3. So a squared will be s squared, which is what? S squared that we have here. Then minus twice the product of your a and b. So it will be twice the product of a is x, b is what? 3. So it will be 2 times x times 3. So that will give us 6x. Then plus what? Your b squared, which is what? 3 squared, and that will give us 9. Your inability, okay, to expand this, okay, will spell doom, meaning, okay, you only get the formula mark here, provided you quote the formula, okay, right. The rest will be wrong because it will be garbage in, garbage out. So if your expansion is wrong here, it will be M2. Your ability to extract that will give you B1. This one, we should all get it. Okay, if this one happens to be above your solution, you won't get it. Okay, all the maths that you are supposed to hear should be below your solution. So if you wrote this on top of your solution, you won't get it. It's not part of your solution, like you've been advised. So after I have expanded, then what do? I go and quote the formula. Someone could have quoted the formula before coming to do the expansion, okay, where need be. As the advice was to, okay, remove all brackets because you know in your substitution you should avoid substituting where you have bracket. So in this case, I come and quote my formula. My formula should be dy dx, that's the first principle formula, is equal to the limit as h approaches 0 of this. If the limit is not there, it will be b0. Please take note. So now the formula will talk to you. So listen and let the formula talk to you as to what to do, like you were told. So then in the formula, okay, I need to know my f of x. I need to know my f of s plus h. But if I know my f of x, I can confidently find my f of s plus h. So my f of s usually will be the function or the relation given. So the relation was named y. So what do? You let f of s be equal to y, which is the whole of what we have here. But okay, remember I said, if you are substituting, you go for the expanded version. So instead of, we know this is the same as this. For convenience sake, we've expanded. So your substitution or your representation for f of s shouldn't go for the factorized form by the expanded version. And that's what we have. If you're able to do that, B1. Okay, so at this point, I know, okay, that if I know f of x, then I'm more than capable of finding f of s plus h. F of s plus h means wherever I see x in f of s, I put s plus h there. So you can see that this becomes s plus h, but because it's a binomial, I put it in bracket squared. Then minus 6, my new x is s plus h, also a binomial, I put it in bracket, then plus 9. And again, okay, I'm not done. Remember, you are going to substitute for f of x and f of x plus h. None of them should involve bracket. That's the more reason why you expanded this. So in this case too, after your substitution, you need to expand and combine like terms, if any. So if you expand this, the same binomial squared, okay, identity to be s squared plus twice the product of this and this. So it will be 2, the product of this and this will be sh. Twice that will give us 2sh. Then plus h squared. Then minus, okay, 6x. Then minus 6h. Then plus 9. We should all be able to expand this. Okay, if you don't know or you are not comfortable using the identity, which I will encourage you to do because it shows maturity. Okay, what you are supposed to do is you know that if you have x minus 3, okay, squared, this is also equal to x is the same as x minus 3 times x minus 3. That's your crude way. Then you come and distribute. Okay, and you end up getting the same thing. But I will encourage you to use the binomial identity, squared identity to expand. So having expanded this, okay, which gives me this. So now I know f of x plus a. So I comfortably go and substitute. And where I'm carrying out my substitution, I write therefore dy dx is equal to. If you don't write the dy dx here and you come and write straight away is equal to, it will come with a penalty. Remember, I've told you once something has interfered, okay, when you are going to make use of this identity or this relation that we have here, or formula that we have here, what do? You write the left-hand side again. So that's what we have here. Is equal to the limit as h approaches 0. Then you go and substitute for f of s plus h, which is the whole of what we have here. Then you also come and substitute for f of x. So it will be minus, okay, then because f of x is what? More than a 10, you put it in brackets. If you didn't put it in brackets, okay, it will spell a doom. In fact, okay, it will be costly. So at that point, you will get M0, then A0, marking becomes easy. Okay, so you don't ignore the bracket and you think we should assume that the bracket is there. And when you move forward, okay, though the bracket is not there, you will expand with the bracket being there. No, that is not mathematics. Okay, so at that point, you are performing magic. So the next step, okay, remember, is to come and remove the brackets here. But we know if you remove the bracket, we are going to get minus s squared, which will cater for or cancel this. Then you get plus 6s, which will come and cancel the minus 6x here. Then minus 9, which will also come and take care of what? Of the 9 that you have here. So it means, in effect, if you expand, okay, this and combine like terms, okay, you are going to get this standing, okay, and this also standing. The rest, okay, will cancel out. So on that note, you come and write equal to the limit must be there. Okay, at the point that you are not supposed to remove the limit, if you remove, it will be costly. It will be M0, A0. So check and use it to mark accordingly. So at this point, my numerator will be 2sh plus h squared, then minus what? 6 what? H. Okay, exactly what you have there, all over what? H. Don't forget. So at this point, what do? You can see that, okay, it's direct substitution. After I've done my substitution and simplification, is direct substitution allowed? I'm taking limit as h approaches 0. And the answer is no, because my denominator will be 0. So at that point, I have to go and do manipulation. Which sort of manipulation? In this case, factorization. So I factor out what? H. Okay, so if I factor out h, I'll be left with 2x as my first term in my second, okay, factor. Then I'm talking about the second bracket. Then plus h1 is gone, so I'll be left with h. Then the h is minus 1, 6. Then I close my bracket. But at this point, I know this will cancel that. So I cancel that mentally, and that would be equal to the limit as h approaches 0 of what? This. If you fail to put this in bracket, it will be M0, A0. Remember, if you are taking limit of a functional relation and it's more than a monomial, you have to put it in bracket. So the next step is to substitute h wherever you see, 0 wherever you see h. So that will give me 2s plus 0 minus 6. So mentally, I know that I'm going to get 2x what? Minus 6. and that will give you A2. So look at the marks there and consider all that I've said in terms of penalties and how to mark. Okay, so at this point, this becomes the solution to the lesson 6 assignment. If you have any issue, please don't forget to let me know via the comment section on my YouTube channel. Okay, so please subscribe, like, and share. Okay, and then may the good Lord continue to be with us. Bye bye.